The key concept in similar shapes really is determining the scale factor. Now the scale factor is also called the multiplying factor over here. Now if you look at this drawings or the illustrations over here, I've got now if you look at this shape over here, it's been scaled up to the green shape, and the scale factor here is 2.2. Here we have a 3D shape which has been scaled up by a factor of 2.5, and that's the result of scaling it up. So a shape can be scaled up by a scale factor of greater than 1, and it can be scaled down by a factor lying between 0 and 1. Now this table highlights something important that we ought to keep in mind while dealing with similar shapes. If we are determining the scaled length, we simply multiply it by the scale factor. If we are determining the scaled up area or scaled down area, we multiply it by the square of the scale factor. And if we are determining the volume of the scaled shape, we multiply it by the cube of the square factor. So we've got an example over here. The original area 64 square units is being scaled down by 2/3. So it's going to be the original area times the scale factor, and we square it. So you can see it's 2/3 whole square, which gives me 64 times 4/9, and it approximates to 28.44. So that's the scale down area. Likewise, this example is scaling up because it's 3/2, and this is volume. So we'll go original volume times the scale factor, but this time cube, and we get the new volume as 36 cubic units. So let's look at this question over here. It says a cafeteria sells cupcakes with similar shapes, and they're available in 3 sizes. The large cupcake has a base of 6 centimeters, the medium one has a base of 5 centimeters, and the small one has a base of 4 centimeters. The question is, determine the price of the larger and the smaller cupcake to the nearest 5 cents. You are given that the middle size cake sells for $3.80. So what we need to determine is the scale factor. So for the smaller cupcake, the scale factor is 4/5, because 5 was the base of the medium cake and 4 is the base of the smaller cake. And likewise for the larger cupcake, that's the base over there, 6 units over the base dimensions for the medium cupcake, which was 5. Now we are trying to determine the cost for the small cupcake, and we are going to use the knowledge of ratios, and at the same time, because it's volume, we are going to use the scale factor as k cubed. So the price for the small medium cupcake is $3.80. So if I go 380 divided by the scale factor, which is 5/4 cubed, that gives me the price as 1.95. So the small cake sells for $1.95. Using exactly the same logic, we can determine the price for the larger cupcake, which is $3.80, the price over there. Now this is on the CAS I've shown you, and we have got 5/6 and volume. So this is how you determine the price for the small cake and the large cake. So because we have to round it to the nearest 5 cents, that's going to be 6.55, and that's going to be 1.95. Let's look at another question over here. It says a central long pole of height x meters supports a tippy tent which is conical in shape with a slant height of 6 meters. So this is the slant height there, and it has a platform towards the top with a height h. So this one over here, this is another platform, and this angle over here is 72 degrees. So the questions are, calculate the vertical height of the tent to 2 decimal places. So it's this height that we are going to determine. The volume of the tent to 2 decimal places, so the volume of the big tent. And then finally it says determine the height of the top section, so this unknown h, if that section makes up 20% of the tent volume. So we'll obviously be determining the total volume of the tent, and then that cone over there is 20% of the volume. So first we need to determine the vertical height. So we have just used a trig ratio. So that's the hypotenuse over there, 6, and we'll go sine of the angle that's given, 72. Now that gives us the answer in the exact form. So if you do Control Enter, it gives you the approximated answer. So we're going to use the answer as 5.71. So we have rounded this to 2 decimal places. I've used the round syntax, but you don't have to necessarily use it if you're good at rounding off. Now over here we're trying to find the volume. So volume of a cone is pi r square h over 3, and we know that the radius is 1.85 and the height is 5.71, and that gives us the volume as 20.46. Now you have seen over here I've used this vertical line. That's a conditional line. It says when r equals 1.85 and h equals 5.71. You could even store these values, but if you're just doing once off, so probably just using the conditional line is good. We are trying to determine the height, given that the top section, the volume is 20% of the total volume. So 20% of this total volume we are going to find. So we need to work with the scale factors. So volume, the scale factor is always cube. So you'll go 20% over 100%, which gives us the scale factor 1 over 5. So we're going to solve this. So we'll say k cubed equals 20 over 100 or 1 over 5, and that gives us the scale factor, which is 0.58. So the height would be 0.58 of the original length, which was original height, which was 5.71. So if I determine that height, it comes to roughly 3.34. Another question over here, it says a 40 centimeter tall conic closed funnel contains 300 centimeter cubed of water when filled to a height of 10 centimeters. So up to that height, the water is 300 cubic centimeters. It says find the radius of the cone up to which the water is filled. That's this radius over here. Volume of the bigger cone in cubic meter. So the vertical height is 40 centimeters, and find the radius of the bigger cone. So that's the radius we'll be finding, and to what height must the cone be filled so that the volume is exactly half. So we obviously will need to determine the volume of the big cone and then divide that by 2. So let's look at the working over here. So the first thing we are trying to determine the radius. So we're given the volume is this, and we know that the volume of a cone is pi r square h over 3, and we are using the height as 10, and we are solving for r. It gives us 2 values. We have to neglect the negative value because the radius cannot be negative, so we'll take the value as 5.3. Now the next part, finding the volume of the bigger cone, we determine the scale factor. So that's the vertical height for the bigger cone, and that's the vertical height for the smaller cone. So the scale factor is 4 units. Because it's volume, we are going to use a cube. So you've seen over here, I've gone k cubed into the original volume, and this over here we are trying to actually determine the volume in meters, and we have got all the dimensions in centimeters. So we know 100 centimeters is equal to 1 meter, so that's why I divide by 100 and then I cube it because it's volume. So I put k equals 4 and volume equals 300, and it gives me the volume for the big cone is 0.0192 cubic meters. Over here I've got the volume in cubic centimeters, but then I need to convert this to cubic meters. So you could use either of the ways to determine the volume. So I've shown over here another method. So k is 4 over 100 this time, and the volume is 300, and we still end up with the same result. You could even store the volume, and then if you store the volume, you'll just go k cube times volume, and you'll put k where k is 4 over 100, and then you get the result. So these are different ways you can enter this information on the CAS. Now we have to find the radius of the bigger cone. So we know that the volume is 19,200. We just found that, and that's the formula for volume, and we know the height. So the only unknown is the radius. So we are solving for r. It gives us 2 values. We have to neglect the negative value. So the radius is 21.41 if we round it up. Now over here we are trying to determine the height of the cone, which will hold half this volume. So half means that I've divided this by 2, and the original volume for the cone is 300. So I want to determine the scale factor. If I use this solve feature and we are solving for the scale factor, we get this as 3.175. Now to get the height of the cone that holds 50% of the total volume of water, the original height is 10, so I need to scale it up by this 3.175 times 10, which is 31.75. So the height of the cone that will hold half the amount of this water should be 31.75.